We're going to be talking about 8.3 comparing populations today. Please pull out your red pen and fill in some of this important information. All right, the first word we're talking about today is an outlier. It's a number that is either much smaller or much larger than most of the data set. Looking at this example that I have here, which one of those numbers would you say is the outlier? 189. 189 is way larger than the other numbers, wouldn't you say? The other ones are 55, 58, 62. Those are all very similar, but 189 is much larger. Take your red pen and go ahead and circle that number. If I was to look for a number much smaller than that data set, what could I have that would be my outlier? No, 55 is a different one that's not there. A number I did not put there. The number 2. What else?
10.
The number 10. Those would be outliers because they're a lot smaller than the bulk of what that data set is. The median, we talked about the median yesterday. Guys, what is a median? It's the middle number, okay? So this is going to be the most accurate measure of center whenever there are outliers. The next thing we're talking about, repeat after me, interquartile range. We're going to focus on that a lot today, but we're just going to call that the IQR. The IQR is the difference between the upper quartile and the lower quartile. Do you remember that from the box and whisker plot yesterday? Okay, so that's going to be the top part of the box and the bottom part of the box. Those are our upper and lower quartiles. Skewed. Read me what skewed means. When one whisker appears way longer than the other. We'll look at some examples of skewed data here in just a minute. And then you want to remember to use the median and the interquartile range, the IQR, when either one or both distributions are skewed. Instead of the mean, it would be better to use the median and the IQR. Let's look at these two pictures right here. I'm wondering if the data seems skewed or not. Look at your notes one more time and remind me, what does it mean to have skewed data? Very good. Looking at the first one, problem A, is that skewed or not skewed? It is not skewed. Write that down. Both of those whiskers look about the same size. What about problem B? Definitely skewed. Why do we say that that is skewed?
One whisker is long.
One whisker is way longer. So what that means is whatever this is out here, that's our outlier. It's the number that's way bigger than the rest of the data set. Two data sets contain an equal number of values. The double box and whisker plot here represents the values in those two data sets. So what we're going to do for problem A is compare the data sets using the measure of center and the variation. Do you guys remember what another name for the measure of center is? The median. It's the number in the middle. So let's look first at data set A. Guys, what is the median for data set A?
That one line over there.
You are looking for the number in the center of this data. Which number would be in the center? 60. Look at that. It's this right here. It's that dot in the center of the box. Okay, so the very first thing would be 60. Now let's focus on the second data set B. Matthew, what is the median for data set B? 80. Not 80. You're looking for what comes in the middle of it. So what would it be? 90 is correct. Now we're going to try to figure out what the IQR is. Go back to the top of your notes and read to me what the definition of the IQR is. The difference between the upper quartile and the lower quartile. Remember yesterday, once again, we talked about this. The upper quartile and lower quartile are the dots that are on the edge of the box. So let's focus on data set A. What is the dot at the top of the box of data A?
30.
The top. The right side. The biggest one.
80.
Okay, it is 80. Look, it's right there. Okay, so that is called, does anyone remember the upper? The upper quartile. Everyone say upper quartile. All right, so right here we're taking the upper quartile, write down 80, and we are subtracting the lower quartile. Guys, what's the lower quartile on data set A? 30. All right, it's this right here. So we're going to take 80 minus 30. Einar, what is the IQR? 50 is correct. Now let's do the same thing for data set B. Noah, what is the upper quartile for data set B?
110.
Not 110. Remember, we're looking at the top of the box for the box and whisker plot. 100. Okay, it's this one right here. 100 minus Angeline. What is the lower quartile? Remember, that's the left side of the box. Not 20. Guys, what's on the left side of the box? 80. So then you can see 100 minus 80 would be what, guys? 20. Notice, I am not focusing on the numbers that are way out here, okay? Instead, I'm focusing on the upper quartile, which is the top of the box, and the lower quartile, which is the bottom of the box. Now, we're not finished with problem A. Instead, it says to compare the data sets using the measure of center and variation. I want you to compare data set A and data set B. Which one has the greater median, A or B?
B.
B. What is the median for B? 90. What is the median for A? 60. So I want you to write this. Data B has a greater measure of what?
Median.
What's another name for the median? A measure of center. It doesn't only ask us to compare the measures of center, it also says to compare the measures of what? Variation. Hayden, what does variation mean? Is that the median or is that the IQR? It is the IQR. So now we're going to compare the IQR. Data A, what was that IQR? 50. What is data B's IQR? 20. Braden, explain to me comparing this IQR with that IQR. What would you say? Which one is bigger? Okay, so we're going to say data A has a greater variation. And that's how you compare the measure of center and the variation, or the IQR. All right, problem B. Which data set is more likely to contain a value of 95? So if I were to look at my number line, this is where on the number line a 95 would be. If I were to go directly up, which box would I land in? Data set B or data set A? I land in data set B. Because of that, it's most likely to contain a value of 95. So we're going to say 95 you would most likely find in data B. Now that's not the only one it's asking us about. It also asks us where we would find the value of 70. What do you guys think? Data A. Look, here's where 70 is. If I were to draw an arrow up, I would land in data set A. So it makes sense that most likely if I had a value of 70, it would be contained in data A. Let's look at the final problem on this slide. Which data set is more likely to contain a value that differs or is different from the center by at least 30? The center has another name. What can we call the center? The median, okay? So I'm going to erase all this stuff up here. Let's focus on the first center we see right here. What number is that at? 60. Looking at that, if I were to say 30 less than 60, what number is 30 less than 60? 30. Is 30 still in the box? Yes, so more than likely that appears to be my answer. Let's say it differs by 60 by adding 30. Angeline, what is 60 plus 30? 90. When you see where 90 is that still in the box? No, it's not, so that probably wouldn't be it. Let's focus on the other one, the center. What is the center of data set B? 90. Isaac, what would 30 less than 90 be? 60. Is that in the box? Nope, it's not in the box. If you look at that, it's on a whisker, but it's not in my box. Okay, Huang, if I added 30 to 90, what would I have? 120. Is that in the box? No. So class, which one of those dots ended up in the box and it would differ from the center by at least 30? Data set A. Okay, because it's right there and it's still in the box. All right, the next problem we have, it's a think, pair, share problem, so I'm going to have you work on it on your own with a partner. It's problem number 3 is identical to the way we just did problem number 2. Okay, so just to help you with this one, problem number 3 says 2 data sets contain an equal number of values. The double box and whisker plot represents the values in the data set. So we've got facility A, and then we have the facility B, and we're looking for how much time they have to wait when they are at these facilities. So the first thing you're definitely going to be looking for, just like we did in problem number 2, you're looking for comparing A with B. What 2 things are we comparing that we compared in the last problem? The median and the IQR. Okay, so I want you and your partner to find the median and the IQR. Einar and Jalen, what did you find for the median of data A? 20 is correct. Noah and Angeline, what did you guys get for the median for B?
20 for the median.
Also 20, okay? So it looks like they both have the same median or the same measure of center. How about the IQR? Reese and Matthew, what did you guys come up with? 10 for the first one, very good, because we took 25 minus 15. Remember, you're just taking the upper quartile and subtracting the lower quartile. And the next one, Hope and Braden, what did you get for the IQR of data B? 20 is correct. Once again, we got 35 minus 15 equals 20. If you and your partner did not get those answers, erase what you have and fix it so you've got the correct notes for yourself, okay? Now it asks us to compare them. On your homework that you have, there's going to be a worksheet. It's going to ask you the same exact things, just like these questions. If it asks us to compare, I want to know, are the measures of center the same? Is one bigger or smaller than the other one? So what do you learn about the medians?
They're the same.
Very good. So I'd like you to write this, put a little star next to it and say they have equal measures of center. For problem A, it doesn't say just to compare the measures of center though. It also says to compare the measures of variation. Remember, the measures of variation, that's our IQR. Who would like to compare the IQR for me? Okay, very, very good. Basically what you said there is data B has a greater variation. All right, excellent job comparing the measures of center and the variation. Now I want you and your partner to answer questions B and C. If you get stuck, you can go back to see how we answered it on problem number 2. All right, let's see what you came up with. Which data set is more likely to contain a value of 30? Who said A? Who said B? All right, looks like everyone said B. Here's the deal. 30, if I were to go up, I would land in the box right there, which is correct. The answer is data B. Let's try the last one. Which data set is more likely to contain a value that differs from the center by at least 15? What is the center for facility A? 20. If I want it to differ by 15, if I added it, it would be 35. If I subtracted it, it would be 5. Do either of those dots end up in my box for the box and whisker plot? No, they do not. So if you put A, that is not correct. How about B? What's the center for B? 20. What would be 15 more than 20? 35. Does that land in the box? So that answers us right there. The one that's most likely to contain a value that differs, in this case 15 minutes more, would be data B. All right, for problem number 4, it says the double box and whisker plot represents the heights of roller coasters at 2 amusement parks. Are the roller coasters significantly taller at one park than at another park? Now this is something I want you to fill in the blank and then also put a cloud with your red pen around this statement. This is what we're focusing on right now. If it's asking if something is significantly taller or heavier or something, to be significant, the difference of the 2 medians must be at least 2 times the IQR. And I'm going to explain what that means here in just a minute. Before we move on, the first question it asks us in our notes is the data skewed? Remember what it means to have skewed data?
Uneven whisker.
There's an uneven whisker. Okay, one whisker is longer than the rest of it. Do you see either data here that's skewed?
Yep.
Yeah, which one?
Park A.
Park A, okay? Now let's talk about specific parks. How many of you have been to a roller coaster park before? Who can give me the name of one of them? Hayden.
Universal Studios.
Universal Studios. We're just going to pretend that Park A is Universal Studios. Let's compare it to a different park. What's another park that has roller coasters at it? Busch Gardens, okay? So we'll say A is Universal Studios, and then Park B is going to be Busch Gardens. Let's focus first on Park A. We're looking for the median. Brayden, what's the median for Park A? Very good. Remember, that's the middle number that's in our data set where the box is, okay? So 50. We're seeing here that 50 feet is the middle number for Universal Studios. Park B, Busch Gardens. Amira, what's the median for that park?
55.
Okay, 55 feet. Now let's focus on the IQR. Angeline, how do I find the IQR? So that's correct. What we're doing is we're taking the upper quartile and subtracting the lower quartile. So she told us that we're going to be taking 55 minus 45. Guys, what's the IQR for Park A Universal Studios? 10. Let's focus on the Park B IQR. Talila, how do I find that?
You subtract 55, 60.
Very good. Okay, what is 60 minus 50?
10.
10. Very good. So as we're looking at this data, here's what it asks us. Are the roller coasters significantly taller at one park than at the other park? Just focusing on our data, which one of these parks has the highest or the tallest roller coaster?
Busch Gardens.
Look at this. Do you see that outlier right there? That's at 70 feet. That one has the highest out of both of them, okay? But you can't just look at them and be like, oh yeah, it seems significant. No, there's a way to tell if something is significant. We put it in the red cloud. What's it say? To be significant, the difference of the two medians must be at least 2 times the IQR. What is the difference of the medians? 5. Notice this. This one is 50. This one is 55. The difference, you subtract them. The difference is 5 feet. Okay? And what is the IQR?
10.
10 for both of them. Is 5 feet 2 times, or is it double the number 10? No. What is it?
Less.
It's less. It's half. Okay? So when it asks us here, are they significant? Write this down. The answer is no. Because the differences of the two medians, which was only 5 feet, that difference or that amount is not 2 times the IQR, which we discovered was 10 feet. All right, for the last problem, I am going to have you work with your partner here in just a minute. What it says is the double box and whisker plot represents the weights of cats at the animal shelter. Are the weights significantly heavier at one shelter than at the other? Remind me again, what does it say here? It means to be significant, class. To be significant, the difference of the two medians must be at least 2 times the IQR. Okay, so as you're working with your partner, remember, once again, you're going to be differentiating between shelter A. You want to find the median and the IQR. And then you're going to find the same information for shelter B. Find the median and the IQR. Okay, then I want you to answer the question just like we did on problem 4. All right, first one, Talila. What's the median for A?
7.
7 is correct. Brayden, what is the median for B? Not 9. Look at it. What's the middle number right here in the middle of it? What's that at? 8. Very good. IQR. Isaac, what'd you get for the IQR for A?
I got 4.
4 is correct. Okay, we take 9 minus 5, which does equal 4. And then, Reese, what'd you get for the IQR for B?
4.
4 also, very good. 11 minus 7 equals 4. Remind me again, what does it mean to be significant? The difference of the two medians must be at least 2 times the IQR. What do you think, guys? Yes or no? Is this significant?
Yes.
No.
I heard yes and I heard no.
Yes. No.
The answer is no. Who can explain to me why this is not significant? Gavin. Okay, so the difference of the medians, as he said, you subtract 7 minus 8, or 8 minus 7. What is the difference of the medians?
2.
8 minus 7 is? 1. Okay, that's 1 pound difference. Is the number 1 2 times the IQR? What's our IQR? 4. The difference of the medians, 1 pound, is not double the IQR. So this would not be considered significant. All right, for tonight's homework, it is going to be an 8.3 worksheet. You do not need to put this on Big Ideas.